Okay, so my tablet decided it was going to die. So we are back a little while later. So this, I guess I'll have to split it up into 2 videos. I don't have any kind of editing software, so I don't know how to make this into one big ass video, but it's already been like almost an hour, so I think splitting it up is good. Alright, so blah blah blah. So what is the question? Graph of 2x to then graph. Okay, so 2, 1, 0, negative 1, negative 2, 2 squared, 4, 2, 1, 1 over 2, 1 over 4. Then x, 2x plus 2 plus 1. I'm not going to write values for that actually, and I will show you why. Okay, on our x, 1, 2, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4. Okay. 2, 4, 1, 2, 0, 1, negative 1.5, and then negative 2.25. Okay, so then we're going to take everything. We're going to move each point 2 to the left and 1 up. So take this point, 1, 2, move 1, 2, and then 1 up. So now we're starting here. And then we're going to go to the next point, go over 1, 2, and 1 up. Same thing, 1, 2, 1 up, 1, 2, 1 up. I didn't draw enough lines, but we're going to keep going. 1, 2. So you don't have to do all this for this one. You literally just take the points that you have and move them 2 to the left and 1 up. And I moved them 2 to the right, didn't I? Yeah, I did. That's the thing about not being a computer. You get right and left mixed up when you're tired. Okay, so let's do that again. 2 to the left. 1, 2, 1 up. 1, 2, 1 up. 2, 1, 2. Okay. Now the graph is right. So, that is that one. And then for the answer, they want you on my math lab to make the graph, obviously. And then they also want you to have the horizontal asymptote, which is the line that the function gets close to but doesn't touch. So it's just y is equal to 0. And when you graph an asymptote, it has to be dashed, okay? If you make it a solid line, you will get it wrong. On my math lab, it'll give you that box. So on horizontal shift, you'll put -2, and then vertical shift, you'll just put 1. And that is how you do that on my math lab. Okay. This is a really easy short question. It's just to see if you understand the concept honestly. Okay guys, let's just look at this for a second. This is an inverse, so that's the inverse of function h. And the inverse of function h, so if we have our x value, and then we have h of x, and if x is -2, then h of x is -4, and this is the inverse, what would h be of -4? Well, you flip them around. So, it's just you've already got the answer. It's -2. And then okay, this is another short one. Answers and not much to explain here. Okay, let's do another one of these. Like I said, you have to have the same base, but we know 5 cubed, I'm pretty sure, is 125. It is. So set those equal to each other now that we have the same base. Solve. I feel like I maybe did this one already, but I can't remember. Okay, and so then answer's 3. On my math lab, you put 3 inside these little brackets. Not parentheses, okay? Next. So, I know that this is going to be 2 just from looking at it, because 32 is 2 to the 5th power? Yeah. So I know that that's going to be 2 to the 5th power. Let's just... and 2 to the 8th is 256. Ta-da! This is going to be 3, because I know 3 cubed is 27. Don't know 81 though. 4 or 5? Probably 4. Yep. There we go. Okay. Uh-oh. A fraction. But do not be scared. We know it must have a base of 2. So, how... if we raise 2 to what power? What power do we raise 2 to get 1 over 4? Well, we know if we did 2 to negative 1, we would get negative 1/2. So, 2 squared is 4. So if we want 1 over 4, that's how we get 1/4. So it's negative 2. Then we just proceed like normal. Okay. Alright. We know our bases have to be the same. We're not doing anything over here, but this we can change. If you don't know, the square root can also technically be written in exponent form as 1/2. If you don't know that, then that's not great at this point. So like some other ones, if you change the number on the outside, always stays on the outside. He wants to die, he's suicidal. Okay, so these are the same. And then same thing. 5 wants to die. Whoever is on the outside stays on the outside. That's a quick explanation, so we'll rewrite that. And then set them equal to each other. Four over 2 just ends up being 2. Add 1. It's 3. Just little things they try to trick you with, like this next one too. So, let's just not look at this for a second. We know from what we said a second ago that anything to the negative ends up being 1 over that number, the base number. So, with this is technically, if I'm not wrong, if I'm not mistaken, I am, in fact, I had the right idea but did the wrong thing. So, we also know that anything in a square root can also be written as 1/2. So, yeah, that's what it is. Took me a second, my head is lagging. So, but what I just said is important, actually, as it turns out. We need the base to be, it can't be in the denominator like that. So, to get the 5 up in the numerator, we can change it to and then we can solve. If you don't know how to divide fractions, 2 is technically 2 over 1. When you divide fractions, you simply flip them and then multiply across. So 1 times 1 is -1, 2 times 2 is 4. So x is equal to -1/4. That one is a lot, but basically you just have to know that these things can happen. And if you've had crappy math classes before this one, not that this one is good, I'm not saying this one is good, then you just not having that little bit of knowledge makes simple problems a pain in the ass. But that's not your fault, and I'm trying to help, so. Okay. Alright guys. I am now going to teach you about logarithm equations and how to read them. Okay. Whatever is down here and is tiny, that, oh dear. That is your base. Whatever it is equal to, that is your exponent. If you can remember those two things, you should be able to convert any kind of exponential function into a logarithmic one. So, let's try to do one. You have 4 is equal to log b 16. Okay, if b is our base, and 4 is our exponent, that is what it would look like in exponent form. Sorry, I should have... Oh no, I've done that thing again. I forgot to change layers. I should have written this first. And then whatever's on the outside is what it ends up being equal to. But if you can remember the base and the exponent, which should be which of those, then you won't have to remember the last thing. So let's just keep trying some more. Oh, that's the wrong brush. Okay, our base, little guy. Exponent, 6. Last thing is the m, so that's what it's equal to. You just have to keep doing these until you remember it, and that's the only way to do these. Keep doing them until you have it memorized. We just did this one, but for some reason it's in my homework twice. Our base, right here. B, exponent, 4. 16 is all that's left. Okay. And then this one, they flipped it around to try to trick you. But we will not be fooled. Base, 5. Exponent, y. All that's left, 25. And by looking at this, we should know that y is equal to 2. But that's not what we're doing. We're not solving. We're just rewriting this in exponential form. All right. Now we're going to do the opposite. Now we need to write this in logarithmic form. So this is our base. This is our exponent. All that's left is 9. I know maybe that's a little confusing, but you just have to keep doing them until you get it. Okay, our exponent is 4. Our base, 13. All that's left is x. $25. Okay, this is different. No, we did. Okay, I don't want to do this one, but okay. Oh, by the way, I don't think we're gonna have a problem. Oh, we do have. No, we don't. If it just says log x, that means it has a base of 10. It won't say that it has a base of 10, but it's a 10 if it's log x. And if it says ln, then that is e. Why doesn't it say e? Because this is math, and we can never say what we mean. So if you had, that would technically be e. Okay. I'm gonna erase this, or maybe if I can make it smaller, maybe I can keep it up here. Okay. Graph. Okay, this is a transformation of a logarithmic function. So it's not like the exponential ones, but if we can look back at our table, we have 2 plus out in the front. It is technically the one at the top, but it is not written. Is it? Yeah? I don't know why they wrote it like that. Would make more sense if it was written like this. But whatever. I don't write the math textbooks. Okay, so we need to graph log 4x. But to do that, the easiest way to do that is to first graph the inverse, which, like I said in the other video, is this. These two things are inverses of each other. So, to find the values to plot points for log 4x, we just use this guy first. Okay, and then for log. One over 16. Okay. And then they want us to go 2 units up. One, two, three, 4. 1, 2, 1, 2. Alright. 1 on the x, 0 on y. 4 on x, 1 on y. 0.25, -1. I knew I was forgetting lines. -1. 0.25, -1. Okay, so that is log 4x, but they want us to move it 2 up. 1, 2. 1, 2. 1, 2. And 1, 2. So the purple is 2 plus log 4x, and then the, I don't know, greenish, bluish color. And then they want us to find a vertical asymptote. The asymptote is the line that is approached but is not touched. So it's the y-axis. remember to graph that as a dashed line. And then they want the domain. The domain is where we can go on the x. So we start at 0 and then go to infinity. Range is the y. Now, because there's no horizontal asymptote going this way, that means it goes on forever. So, and the vertical asymptote is x is equal to 0. And that is that question. You will simply have to remember the transformations of each, okay? So look at those tables and memorize them. That's the only way. Okay. Okay. Really simple. Even though they certainly didn't teach it that simple. The domain of a logarithmic function has to be greater than 0. So you just take this exponential, I don't know if that's what it's called. You take the little guy on the end that's in the sky, and you make him greater than 0, and then you solve. So x has to be greater than 7. So if we wrote that in interval notation, that would be it. Pretty easy once you know what you're doing. And next. Okay, same thing, has to be greater than 0. X cannot be negative, so we have to multiply by -1. We know that when we multiply an inequality by a negative value, we have to flip the sign. So x has to be less than 6. That's our domain. Because if we had a number line, everything less than 6 would be this way. So that's why it's negative infinity to 6. Whoa, what the heck? 50, jeez. Sorry, I got a notification. Okay. Alright, we know that this is E, but in this question, it's not important. We know that this has to be greater than 0. So looking at this question, what would make this 0? Obviously, if x was 15, 15 minus 15 is 0. So we know that 15 cannot be in the domain. So we don't need to solve anything. We just need to exclude 15, because even if you had a negative value in there, even if you had -1 minus 15, so you had -16 squared, anything squared is going to cancel the negative and end up positive. So really, the only thing we need to exclude is 15. And that is how you find domains of logarithmic functions. Okay, what's next? Da, 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 da. Not numbers. Sorry, I connect my letters to my E's. That is a poorly drawn U. Okay, so let's look at this. Let's ignore the x's up there in the exponents for a second. What is 8 squared? 64. What is 4 cubed? So if you know squares, 4 squared is 16. What's 16 times 4? It's 64. So I hope you know now just by looking that yes, this is going to be true because they are the same. So no matter what you put in here, they will always be the same because they're both 64. Okay. Okay. So to figure out what this is, we can change it to exponent form. This is our base. 2. We don't know our exponent. 2 to what power is equal to 32? It's 4, right? No, it's 5. Yes, so the answer is 5. You just solve for what you don't have. Okay, let's do another one. Alright, our base right here. 3 to mystery exponent is equal to square root 3. Well, we know that square root 3 can also be written as 3 to 1/2. So the answer is 1/2. Let's do another one. Alright, base 4. It is 1. Not much to explain with these. You just have to do them and then you'll... That's how you learn them. Let me just mess everything up. Okay. No. Well, you got something like this, and you're like, what the hell do I even do? These questions are actually really simple. So if you see anything that looks like this is always going to be your answer. The guy that's hanging out at the very end, he's your answer. So it's 2. You don't even have to do any math. You just look at it. Oh no, whoops, this is a different one. Okay, our bases have to be the same, so it's gonna be 2. Okay, because it's in absolute value bars, it's actually going to be plus or minus. So what you would type on my math lab is this. That would be your answer. Okay. Let's see, is there anything else? No, that's everything I have. But let me just double check back through my quizzes and make sure there's not anything that I haven't done. And there is. Okay. Okay, so like we just did with our domain questions, we know it has to be greater than 0, but this hasn't, we have to factor it first. So what adds to 6 and multiplies to -7? It's going to be x minus 1 and x plus 7. I'm not doing the box at this point, guys. You should know how to factor by now, and if you don't, you can watch me do it in other videos. So we just take these equations? Gee, I don't know what to call them. You take these and make them all greater than 0, and then solve. And then we make our domain. We exclude -7 and 1. And that's our domain. So that is how you would do it for a problem like that. Let me look at these questions some more. Nope, we already did all that. Okay, I'm not going to do this one all the way out, but I will write it just so I can tell you what you should do. Oh no, that's from like a couple weeks ago. That's just, you know how sometimes when we do the homework and then they add stuff from like a couple weeks ago in there, that's one of those kind of problems. So, yes, okay. Yep, that's everything. So just things to remember. Okay, and then obviously the transformation tables. Okay? Right. Good luck with the over 100 questions this week.